Okay, part two. This is part two. We're going to look now at the cubic function. And the last one we talked about, the general graph, was a rainbow. And on this one, and I tried to find some music and I couldn't. On this one, your visual is a snake. Okay, it's a snake. Now, where does this come from and what parent graph is this? This is a cube root function graph, parent graph. Where does that come from? Well, what's the inverse of the cube root? A cube. So where does this come from? If you have y equals x cubed, we know that that is a snake going up as the parent function. If we switch our x and y's, so x equals y cubed, and we undo a cube. To undo a cube, we cube root. So cube root both sides. So we end up with y equals the cube root of x. So what does that do to our graph? Remember, this snaked up. When we snake up and we reflect it over the y equals x line, that is our new x, our cube root of x graph. There we go. That's the parent graph. Notice we are going through the origin. Notice the domain goes left forever, right forever. So it's all real numbers. Notice the graph slowly rises up and slowly goes down. So the domain, or the range, is all real numbers. So of this parent graph, the domain goes left to right forever. So you can write it two ways. It's all the x's. The x is all real numbers. You can write it like that. You can say from negative infinity to positive infinity, right? So those are two ways to write our domain. The other, now let's look at the range. We just said that it goes up forever and down forever. There's no limit on our output. So how do we write the range? Same way. Range, and I'll try to make this dark so you guys can see it, is all the y's such that y is the set, little e, of all real numbers. Every element of real numbers goes up forever or down forever. We can also use negative infinity to positive infinity. Again, all real numbers because the graph goes up forever and down forever. Okay, now let's look at the shifting. The AH and K with the cubic function is very much like the square root function. We're just going to do the AH and K with the snake graph. Okay, so here is our parent graph of the cube root function. It's coming up, it's sliding through the origin, and it continues to rise. Now, I like to focus on the origin and what happens to it. Okay, a cube root x minus h, all under the radical, plus k outside the radical. Exactly the same as the square root function. What does a do? What does h do? And what does k do? Well, a in the last one, we just talked about it. If a is greater than 1, it's going to stretch it above this one and below. It's going to stretch it away from the axis. What does the h do? It takes what was at the origin and shifts it left and right. What does the k do? It takes what was at the origin and shifts it up and down. Okay, exactly the same thing. Now, if a is negative, it's going to reflect over the x-axis. It's going to take it from here and reflect it under, and this arm is going to reflect over. So let me draw that in red. What does a reflection or a negative a do to our graph? Negative a reflects this one over, so this one's coming over, and this dashed line, this one comes under. So there we go. It would reflect it over the x-axis, just reversing it. Okay? That's all the negative a does. A, if it's greater than 1, we'll stretch it tall. If A, absolute value of A actually, is less than 1, it will make it tighter to the axis. It will still snake through, but it will just be closer to the x-axis. Okay? So that's the effect of A. H and K, just take and shift what is at the origin, shifts it horizontally for H, vertically for Y. So let's look at an example of that. Let's do an AHK shift. So starting with the equation 3 cube root x minus 1 plus 5. Okay, first let's identify AH and K. A, 3. H, positive 1. K, positive 5. So 3, 1, and 5. Take our parent graph. So here is just an XY axis. I'm going to take my snake and I'm going to shift it horizontally 1. So I'm going to the right 1. And then I'm going, since K is positive, I go up 5. 1, 2, 3, 4, 5. So my parent function that was at the origin now snakes through 1, 5. So 1, 5 is my HK, and that's the point where it's going to change. Okay, it was snaking through right here, the origin. This point just went over and up, and it's going to snake through here. Now, what does A do? A is 3, so it's going to stretch it away. So what if this was the parent function, and it was at 1, and the cube root go out to 8, 1, 2, 3, 4, 5, 6, 7, 8. This one actually should be at 2, because the cube root of 8 is 2. So it's pretty tight anyway. It's going to multiply that by 3. So it's going to stretch it wider and taller away from what would have been the axis. And I'm kind of running into my words, but you get the idea. It's going to be a little bit stretched out away from this point right here. It's up. Okay, that's what AH and K do to the cubic function. Now let's look at a couple quick examples of those graphs. Okay, so the first one, let's just plot the parent graph for a second. And I'm doing pretty good on time. I'm only 7 minutes in. Let's do the cube root of x, just the parent function for a second. And we're going to look at some points that are on that. We're going to look at -8. We're going to look at -1, 0, 1, and 8. And the reason I chose these numbers, they're perfect cube roots, aren't they? Because the cube root of -8, the cube root of -8 is what times what is -8? And the answer is -2. Cube root of -1 is -1. Cube root of 0 is 0. Cube root of 1 is 1. And the cube root of +8 is +2. So you can create a graph just of those numbers. So 0, 0 is my origin. -1, -1. -2, 3, 4, 5, 6, 7, 8. And -2. So you can see it's pretty tight to the axis as far as a cube root. So 1, 1, 2, 3, 2, 3, 4, 5, 6, 7, 8, 2, and there is the snake. And it will slowly rise. Now the next kind of even number would be 27, wouldn't it? Because the cube root of 27 is 3, so that's going to be way out there at 27 and up 3. So it's slowly rising. It's not rising very quickly. So there's the parent graph. And that's the one you're going to shift up, down, left, right, stretch, or reflect if A is negative. So there's the beginning of the AH and K with the cubic. And you guys hopefully watch the squared one. And I'm going to do an example of each one of those in my last video, and it should be short and sweet.